present at Open Autonomy Inc. And there he goes again. And he received a Bachelor's of Mathematics from the University of Waterloo in 2005 with honors in computer science, and spent most of his professional career building parallel garbage collection for IBM. He's now currently building Open Autonomy Inc. as a technology startup to solve problems with online walled gardens, and here today to talk about beyond open source federated systems.
All right, so yeah, thanks for the introduction. So I'll try and get through this fairly quickly, but one of the ideas as well is if you have any questions as I'm going through, like I do want to have sort of time at the end to have actual Q&A, but also if there's something specific that you think is misleading or you want me to address right away, just put your hand up and I'll kind of get to it before the end of the slide, because I want to make sure I don't get off on some tangent that someone's missing something. So yeah. Oh, one of the things I also want to mention is if you're interested in issues such as federated systems, Blaze is doing a talk in this room in an hour, which is closely related to this area. But we made sure that we're not going to be redundant or anything, so they'll build on top of each other, not actually be conflicting. So what I'm going to talk about is how the ideas behind kind of the open source movement, how we've kind of grown beyond what some of the protections those gave us were, and what we could do to kind of extend those into kind of a new era where everything's kind of network connected and remote services. So it's all about federated systems. So just to give sort of a background about how I'm going to be going through this, what I'm going to be talking about, so I'm going to just do a quick rundown of kind of what I mean by walled gardens. This is a concept that we're probably all relatively familiar with, but just to make sure that I kind of communicate what I mean. Talk about why open source on its own isn't enough to solve those specific problems, why we need something that's a bit more. What does open source itself actually mean in terms of what did we actually benefit from the open source movement? What were some of the core principles that actually were beneficial to us there, and how do we sort of move those forward as the problem changes underneath us? Which brings me to actually trying to apply this to federated systems. Okay, well, what does federation mean? What is a federated system? What are some examples of how we're doing this already? How we actually have federated technology within the internet? And there's some of those things which are already solved problems. And then we look at distributed social networking. This is a sort of it's sort of the classic problem we're trying to solve, the one that a lot of people are dealing with directly, saying that what's going on with social networking is really causing some problems, and how can we solve that? So distributed social networking is really sort of the perfect next target for using federated systems and federated technology. And I'm just going to kind of wrap it up with talking a bit about some of the open source opportunities through open autonomy, things like what we actually give out and how to find that information, and kind of the components involved there. So first of all, with walled gardens, this comes down to the idea that you have sort of an inside and an outside. On the inside, you have this central absolute authority. So they're going to define the information that's available itself, what you actually can say, but also the software, meaning how you can say it. So not only are you now subject to some external, this sort of authority that actually controls the system in terms of talking about what you can and can't say, which may be a concern for you, but also if you want to do something like build a piece of software that actually kind of uses this the existing communication networks or the existing data in some way that you want, you may not be able to. There's going to be strong limitations in terms of what you can really do, because the software isn't something you're running. It's something they're running now within this walled garden. And those of us, of course, on the outside have either no access or limited access to the system. So this is the kind of problem you get where someone sends you a link to something online, and you click on it and you get a login panel instead of getting information. And this is, of course, a huge problem. It's really counter to the purpose of the internet and where we're going. Now, this also brings up some other questions, and this has been a huge issue recently with concerns like NSA spying and the idea that your data is being harvested for marketing reasons. Well, who's listening in on this and why? Who actually has access to the information or even the associations between people and ideas that you're actually putting in these systems? What are they doing with that information? And part of the problem you have with these environments is we don't really know who's doing that, and there's really no way to find out. It also creates a single point of failure. So yeah, sure, they're actually going to be load balanced and geographically distributed within any one of these services, but there's still this idea that if someone wanted to control your access to one of these services, it would not be very hard. They're essentially, you want to stop people from organizing if they're trying to protest against something your government is doing, well, we'll just mess up the DNS record for Facebook and suddenly they lose the ability to talk to each other, which doesn't really make any sense because they were kind of all nearby. And there's lots of problems related to that which come up. So open source on its own isn't enough because the real question is, what does the source actually give you? And this is where we run into the limitation. For example, look at Facebook. If you had Facebook source code, you could not run Facebook. Not because you don't have the hardware, maybe you could, but because it's not about the code. It's actually about the networks within it. So all of these users on their existing system, they're not going to migrate to yours, and there is no compatibility between the two. They are built to be distinct entities that control the world. So it's not the code that's going to help you, it's where the users are. Now, a slightly different example, which is not quite as concrete and not as severe, but kind of points out one of the other issues related to this, which is if you had, say, the code for Google Docs, well, you could kind of run it, but all your data already exists somewhere else. So you have to move that for you. You have to move it over to where you're putting this now. Who really owns the data? If it's physically within someone else's data center and they physically control the software used to manipulate it, on which level is it yours? I guess you have a password somewhere and that kind of represents ownership, but is it really the same? And do you migrate all your data through just a million copy-paste operations? So what do we need beyond the source itself? What's sort of the next step to take this forward? And to that, I think we need to look at some of the core ideas behind what open source really meant to us, where the benefits were, and why it ended up being so useful for us in the first place. Because it wasn't just about moving source code around. No, it's about the principles behind how we actually needed that. And this, now there's going to be as many different interpretations and definitions of this as there are users, but I've kind of whittled it down to sort of 3 core ones that I see come up a lot as sort of why people like open source. The first one is it's educational. Well, this is just great, quick start learning opportunity. You want to know how to do something, why not look at how someone did it? Right, then you can learn it that way. And a lot of people, especially when they're just starting out in something, this is a great way for them to just see, okay, how do I conceptualize a problem of a certain size? How do I understand how to perform this kind of operation? So, well, you look at the source, right, RTFS. Another one is the free as in beer idea. A lot of open source software is free. You don't pay Apache a bunch of money to download, compile, and run a web server. You often will pay for something like maybe you wanted documentation or services associated with it, support, and maybe if you wanted them to fix something for you or add a feature for you, well, you're going to be paying someone to do that. But just to get it as it is right now as this sort of single packaged idea, that usually doesn't cost anything. So to a lot of people, it was just that availability of free software in a monetary free sense. And the other big kind of pillar is the free as in speech. And this is where it comes down more to kind of a right that you believe you possess. The idea that you have some sense of freedom within the world. And this really comes down to making sure nobody can control you. You're no longer subject to the business whims of some company providing a product. If they decide now they want to be purchased by another company that maybe that you have some incompatibility with, you're no longer sort of up the creek. There's always some way that you can get out of this. You can either use the source yourself to liberate your data or your processes, or you could at least pay someone else to do it. There's at least a way to get there from here, no matter what was going on. You weren't completely tied down. So how do we apply these ideas to what we're doing now on the internet? Well, a bunch of these things are quite clear. Things like the educational case. Well, as long as you didn't need to know how that particular product works, you could probably find the source to something that would help you out. There's the free as in beer. Well, most things are propped up advertising anyway. So for the most part, you're not really paying out of pocket for a lot of what you're using. You're paying in one sense, but at least not money. But the free as in speech, the idea that nobody can control you, this is something that we've sort of we don't really have an answer for this one. So this is where I say that federated systems are kind of the way forward, the thing we need to look at as we kind of expand upon this. So what is federation then? Well, at its core idea, it's just a collection of semi-autonomous components. So individually, each of them represents something autonomous. They don't necessarily need to be connected to the entire federation in order for them to function. They can basically function just as they are, or as a partial network that still has partial capability. It isn't an all or nothing, and it's not monolithic. So this means that they need some notion of interoperability. Now, in a technical space, this is going to mean something like, well, there's some sort of protocol. Like when you're sending email, there's a protocol for how to do that. Things like this, it comes down to that kind of the technical language that actually fills in the barrier between these autonomous components. And this, of course, is to facilitate at a basic level information sharing. All of these components either represent data or they represent capabilities. So your interoperability is how you expose that across them. And data and information sharing especially becomes important when you do start looking at things like federated social networking, because there's issues of where does information actually live, and that factors into some of your decision making in the design choices. Now this leads to sort of a decentralized organization concept. There is no center of it. The internet on a whole kind of already is organized this way. There is no center of the internet. The fact that we've elected to make a few centers of the internet is more of a bug than a feature. But at its core, we shouldn't be limited by those things. So what are some, just so that I make it clear, this is not something brand new and crazy. This is sort of like, no, we've already done this before several times. And in fact, sometimes when we've done this, if we've managed to continue caring about those factors, the federated systems have lasted longer than any closed analog, because everyone can become involved. You're not limited by one company. So an obvious one, of course, is email. Well, you're all a user at a server. There's no email corporation. There's no Mr. or Mrs. Email who receives, who you buy stamps from or something like that. It's something that everyone could kind of play along. Everyone had a vested interest in becoming part of this game. And they could compete there with value add and all those things. So this is basically just a data exchange system now. And it's passive. Now, one of the reasons I want to point that out is that it's something that's fairly low cost in terms of computation. If you're not receiving email, you're not on the CPU. So it doesn't matter. This makes it easy to deploy this. Now, another example, which is more recent than that, of course, is XMPP or Jabber, which is, for the most part, people use it as an instant messaging system, but it can do a lot more. Now, instant messaging at its core is presence, the idea that you need to be able to tell people you are there and have them be able to track that information. Now, this is an active idea because presence is an active activity. You can't be only running when someone's looking at you, because in a presence network, they're sort of always looking at you. And this, of course, is the basis for primarily instant messaging, but they do other things with it as well. Now, OpenID is sort of another one of these I think is worth mentioning, because it's actually, the problem it solves, which is federated identification, is actually sort of part of the overall distributed social networking issue that you'd need to solve. It is one component of that you can have kind of this single sign-on for the internet. And that's really kind of part of what we're going to have to do anyway to solve some of these other problems. So it's another example of that. And of course, it's passive too, because unless your identity broker is directly answering an identification request, it's not doing anything. So the next big one, of course, is the one we have today, the distributed social networking. And this is a huge problem. If you look at something like the list of distributed social networks on Wikipedia, it's like, I don't know, there's like 100 of them or so. Lots and lots of people are trying to solve this problem. And so I'm going to talk about sort of some of the issues related to this, and because through open autonomy, this is also one of the problems that system solves, I'm going to talk about just some design decisions that have been made with some of these different organizations and how they've tried to solve the problem, and some of the differences that come about because of that. So this is all about fixing that walled garden problem. Now, this is only one way of looking at the walled garden problem, but it's a really, really good one because we have lots of examples. So you have to answer questions when doing this, like where does the data itself actually live? And what can data do? Are we just talking about data, reading and writing, key value pairs or something like that? Or are we actually talking about capabilities that are exposed by different components? And this changes how you look at how to solve it, depending on how you want to answer these questions. So I'm going to talk about three sort of different approaches. Now, the one which seems to be by far the most common is what I refer to as the server-oriented approach. The idea where it's sort of building distributed social networks the way you build email servers, where there's a user at a server. All their information is effectively contained within that. Now, there's interaction between servers, but it's all really about the user containing data within one place. And this seems to be by far the most common way of trying to solve this problem by looking around at some of the solutions that do exist today. Now, the other one I wanted to talk about in detail as well is application-oriented. Now, this is how open autonomy works. It's where instead of things being based around users in servers, now you're instead just talking about applications, basically just web services effectively, that exist as this kind of complex mesh across the entire internet, where one user can actually be, their capabilities can be scattered across multiple machines and multiple domains. And some of the changes this has in terms of how you have to look at it. And one of the other approaches, which I don't know of any actual solution using this, but every time you try and talk about these ideas, this is one of the questions that gets asked, is why not use a blockchain approach? Why not solve distributed social networking the same way you solve Bitcoin or Namecoin or something like that? And I'm not going to talk about this in great detail because there's no examples of people doing this that I'm very familiar with, at least. But it does raise some questions, such as, does every node maintaining the blockchain have to have a copy of everyone's data that they've ever put on this? And what kind of limitations exist in terms of what they can actually do? And how do they pay for that storage and that computational overhead of maintaining information in this blockchain which is replicated everywhere? And is there a finite size to it? Things like that. Questions which are complicated. So looking at this kind of from a diagram perspective, server-oriented is all based around the idea that you have servers. Everything sort of starts with that. The server itself is actually what gives you the federation machinery, the protocol for connecting the dots. Within that, you're going to have some collection of users and some kind of data. And now, often in these systems, and this is going to be potentially a bit of a simplification, but it's often based on the idea that data exists within the server, and there's this concept of data having a type. And the capabilities of the server define what data types it can understand. So in this case, for example, the purple data is not the same as the green data. They're different types. They're effectively different kinds of applications using this. So a user has data ownership, and they have some sort of data access rules that they can describe, things like permissions. But all the data that they own is on the same server where they live. Now, of course, you can have connections between users, and potentially those connections can go across the actual server boundaries themselves. Now, in this case, we have something where server A does not understand the purple data, so the line connecting it is dotted. So in that case, you'd have something where, okay, yeah, it can access that data, but perhaps it's either going to ignore it because it can't understand it, or just not ask for it. So this is sort of a common model, and it has a certain elegance to it because it means things like extensibility are fairly easy to implement. You don't worry about what it's going to mean on the actual federated data communication layer. That's just something the server handles for you. You just define a new data type, and you can now perform different kinds of operations. If another server doesn't have your extension, it'll just ignore it. So this makes it fairly easy to do this. But of course, there's also a lot of limitations, which is part of why with open autonomy, I went a different direction with this, which was instead of it being about data, it's more about all of these things on this slide. Since they're just data items, there's no ability to ask some operation to occur. You're instead just reading and writing data tuples. And again, there could be certain implementations which do it a little differently than this. But also you have one of the other issues, which is that all of your data for one user is now in one place. You can't do something like say, okay, I want all my social networking handled in this system. Okay, now I want to maybe add some sort of offsite cloud storage backup or something like that, which is one of the use cases I want to deal with. And well, that has to now be in the same system. It has to be on the same server. There's kind of, for every user, all their information goes in one place. So it is simple, but does have a few limitations. But because they were only looking at solving, this is for the most part, when solving that distributed social networking problem, it usually isn't really a problem. That's a limitation they're willing to absorb because it keeps things simple and they're still able to solve their problem. Now, looking at it from an application-oriented perspective, this is sort of another example of how you can use federated systems to solve one of these situations. Now, this is based more on the idea that it's not about data, it's about applications and capabilities. So in this sense, you've got a collection of, instead of data items, it's actually effectively web services. And there's some ability for them to communicate with each other in a way where they have trusted communication, they know who's talking to them, things like that. So I'm going to actually draw the servers last on this slide, because in this case, they actually don't factor into it. But it really comes down to, we have a bunch of users. Now, in this case, because there are no servers, or at least the servers are not part of the design of how the system would have to work, when you're looking at how the federated communication is managed, how you decide who you're talking to and what they're allowed to do, it all has to actually go through some abstraction of a user. So in this case, we'll say that, okay, users are also just the entry point that you use. We'll say it's just another kind of application. And these can be connected, because remember, users want to be able to describe whatever their actual in real world, or at least in some sense, networks are between other users. They want to be able to grant access to each other and know what's going on relative to each other. Then each of them can actually own some collection of applications. Now, all applications in this system, just to keep it simple, are owned by a user. And in this case, you can see it's kind of a similar diagram to what I had last time, except instead of it being about data and types, it's about applications and capabilities. All these applications have some sort of protocol that exposes what they can do and how you ask them to perform it. And in this case, all of the actual, like the extra complexity that you see in this kind of situation is that now all of those protocols need to have some notion of what the actual kind of federation protocol itself is, because they can't rely on the idea that, oh, the server does it for me. Now, of course, it's not some monumental amount of effort. It's basically just some software library you link in that would do this for you. But it is something that changes kind of where you draw some of the lines when you come down to design it and actually going to deploy things. So just as an example of how you could draw this, let's say the servers are like this. Now, some of the users actually have capabilities that are not where they live. So this solves some issues like, yeah, maybe I want to have, say, offsite cloud storage on 10 different systems, and then kind of treat it almost like a bit of a, use the internet like my own personal RAID. Well, okay, you could do that when you have a system like this that's based around kind of breaking those boundaries. And of course, one thing to consider about this too is the way I've drawn this, where there's sort of the three different servers here and how everything's partitioned around those, is fairly arbitrary. It just allowed to show some of these connections in interesting ways. You could actually build this in a totally different way, where, say, all the components here are on one server, or all of the components here are on their own server, all independently. It doesn't matter from the perspective of how it actually would work. It becomes just a performance concern by that point. So kind of getting past that then, and if it is something that you're sort of interested in, or at least wanting to know kind of how some of the parts of it are put together and what you can look at. All this is available. All the source is released under MIT license, essentially because it was concise, and it doesn't limit what people can do with it. The server reference implementation itself is available, and it's PHP, which was basically just to make sure it can be deployed anywhere. Because yes, this has been tested on anything from fairly high-end VPSs, all the way down to your $5 a month web host, all the way down to a Raspberry Pi that I've got. So it kind of runs however you want it to. It's just an issue of performance, really. But relatively little of the functionality is affected by running it in very restricted environments. There's also part of the open source offering is client-side applications, which are written in Java. These primarily are basically just to show off kind of how you could interact with a system this way. A lot of this is demonstrations of the capability, but they do actually work. This is providing things like, if you want to have things like file synchronization to a backup system that's built on top of this. That's one of the use cases that I have that I use a lot, for example. And because that's part of the reference implementation, this is sort of the do-it-yourself Dropbox or Google Drive, right? Just get this, put it on wherever you've got space. Maybe it's something you're buying, maybe it's some friend of yours who's lending you web space or something. And you just kind of connect the pieces and it'll work. There's, of course, the RPC glue layer, which is because it's all based around application protocols now, well, there's a way that you can actually describe those protocols. So this is if you were to take it and actually try and extend it further. The actual machinery exists to do this for you. So you would specify this as some sort of, some RPC specification, written in some simple XML file, and there's some sort of free marker-based Java support for actually turning that into all your incoming and outgoing glue code for PHP and Java. And I keep meaning to do one for Python. And something which is from an open source perspective is more just an interesting curiosity, but is actually part of the system as how it's deployed, which is something called the P2PC compiler, which is a PHP to PHP compiler, which essentially just does some inlining and dead code elimination and things. Because deploying systems like this based around PHP can be kind of unwieldy due to include path management and things like that. So this is more something that you'd be looking at from a perspective, how does something operate on Bison grammar files, things like that. But those are, again, just tools that are available for everybody if they're used to that. So all that information is available. It's all linked through openautonomy.com. For the most part, the actual code is all hosted out of SourceForge. So are there any questions or comments or rants or anything? Because we do have, like, how much longer is it in the slice? Well, until the next one starts. So. Yeah. But yes, any questions or anything related to this? It's got to be something.
So, maybe I missed something, but I would like to know the difference between the application-oriented and peer-to-peer. And peer-to-peer, right? So the last example that I gave, the last case for federation, right? The application.
Yeah, the application-oriented approach to this.
So yeah, the difference between this and peer-to-peer.
It basically has to do with how the discovery actually works.
Okay.
And who actually decides, because there's the issue of essentially what you're building is it's a multi-application system with multiple owning users, effectively, is what it looks like. So each of the components need to be able to find each other, and they do that. And also, when they find each other, they need to know how much they're allowed to talk to other people. Like, okay, if some application starts talking to me as another application on a network, how do I know who owns that application? How do I know if I trust them to talk to me? How do I know that they're allowed to talk to me? So that's how and also how did it find me? So the idea is in those situations, the components all find each other through sort of a shared user relationship that they already have.
So you still use servers? You still use servers for for example, I can see that you wrote server reference implementation. So I'm assuming that behind this application-oriented, there's a server behind this that does the bridge between users, right?
Well, it's essentially just more of a common library that they'll use. Like, it is running on, it's running as some set of PHP applications on top of Apache. So that actually does run this is how it's executing. But the actual way that the communication itself is mediated is all based around essentially what's this one library. But something that you did mention, which I want to also point out, is that part of the advantage of having a system like that is that if you aren't exposing any services or any capabilities, you're just consuming them, then there's no real need for your application to even be reachable on the internet. So this is where things like you can actually have native applications that interact in this kind of this application mesh, which is actually alluded to up here. The client-side applications are examples of that, how you actually interact with a system like this without actually having any web components at all. Like, aside from this one centerpiece of it and the services that are being offered, any of the consuming applications don't actually even need to be running on a web server. But does the first part of that answer your question?
Yeah, I think I'm having a hard time understanding how the application-oriented approach really works. I mean, you have your cell phone, for example, or I have mine. So, in the classic federated scenario, we will be using, for example, a server between us, or a GNU social server, for example. But in your application-oriented scenario, I'm having a hard time figuring out how it really works for me to communicate with you. I mean, for me to find you and to send messages, or is it peer-to-peer, as I said? I mean, does my cell phone communicate directly with your cell phone and or?
No, in this case, they'd all be based on the idea that the applications themselves are finding each other through user relationships. The user relationships are like the discovery issue of how you actually find other people that...
Like web of trust, for example. Like a web of trust.
Yeah, exactly. Okay. It is a web of trust system.
All right.
And it's just kind of how they step through that. That's a decision.
All right. So I wouldn't call this federated system. I wouldn't call this federated system.
Okay.
But I think it's a major improvement over the classic federated system scenario, which you still have a server, right? And you still don't control your data sometimes. So in your scenario, you are in control of your data because you run your own application that communicates.
Yeah, this is the reason why. Like, the reason why this would constitute a federated system is because it's interoperability between semi-autonomous components. Like, any part of this can disappear, and as long as it wasn't the part that that was the thing that tells you what you can do, which is a personal connection in this case, then everything else will still work. And even if that were to happen to you, no one else who's using any system related to this is affected.
Okay.
So there need not be any connection.
All right. Okay. Thank
you. All right.
What sort of major security concerns have you dealt with, and how have you dealt with this? Security is a big concern these days.
Yeah, one of the things that I've looked at is, first of all, I don't think that as an actual implementation example, I don't think that Open Autonomy has been pushed enough to really get a lot of the examples of that fleshed out. I know that one of the concerns that I've had when looking around at some of the existing discussions that come about when people look at building how they're going to implement a solution like this, because one of them comes up every month. There's sort of this interesting problem they have about deciding, okay, how many levels of the stack do we have to solve ourselves? And so some of them will do things like say, okay, here's how our encryption system will work, or this is how our hashing system will work, or something like that. Whereas others will say, okay, this is how our communication protocol works on top of pre-existing SSL connections. So they assume things like HTTPS already exist, which is the assumption which Open Autonomy makes as well. But that's been one of the things I've noticed is a big difference between these. And because it's sort of a hot issue, it isn't something that I think, gets as frank a discussion as I'd really like to see, because it's very easy in a lot of these situations for people to just panic and say, no, you need all security all the time in all parts. And that's not the same thing as actually solving the problem necessarily. It's just sort of, you know, saying trendy things. So, but yeah, I think that it is an interesting issue because there isn't sort of one answer to it. And it seems like there should be a bit more of a kind of common baseline decision below this, just because they're actually all trying to do sort of the same thing.
It's designed for HTTPS in mind, assuming it's there.
Yeah, this system is. Some of those systems are. Some of them actually have their entirely own protocols. And it really just depends on how they wanted to deploy it, how much control they wanted over some of the ways the system worked. As far as I know, most of them are using sort of an HTTP or HTTPS abstraction. But not all of them, because I've seen some recently that don't. Any other questions or comments or anything related to this? Yeah.
From a standpoint of who's going to use this, this seems more like an OpenID type of person project. So the same type of person who's going to set up their own OpenID server would set up something like this. Am I wrong?
That's basically, no, I think that's pretty, I should be repeating these, sorry, for the recording, but yeah, the question was, is this situation something that would be kind of targeting the same kind of people who would be setting up their own OpenID, kind of identity broker? And yes, they would. These are very similar to, in terms of, I think, the mindset regarding the people who'd be looking at this as being the same. You easily be looking at the same crowd of people.
Do you think that it would be easy to expand the usability to people who are more comfortable with Facebook Connect? Or the ability for the people who set up their own autonomous system to be able to have their friends and family, as an example, also part of their system? Or does that not seem...
Is this, you're wanting to make it...
For more users, like how do you, I guess the layman's version of my question would be, how do you plan to get a lot more users?
Okay, so the question is, how do you get more users on this kind of system? And how do you do things like make sure your friends or family, for example, could actually get online with this as well?
I guess how does it scale?
Yeah, okay. So in that situation, any one of these, basically anyone could run one of these, but because whenever you're setting it up somewhere, it's going to be some software which runs for, it doesn't matter how many instances of users you have, they're just a different instance of the application running there. So in those cases, if you were to take something like, say, the reference implementation, it should easily on its own scale to 1,000 or so users before things start getting unwieldy in terms of just how it is implemented. The actual kind of the cost of a lot of the inter-application connections really depends on what the density of that network is. So that the kind of broader question of scalability sort of depends on what you do with that. This has been sort of similar to some discussions that have gone on regarding XMPP, because there's been concerns there of what the actual kind of internode scalability is. And that's also kind of, it's sort of a concern that gets voiced every once in a while, but it does not appear to have really grounded anyone. So there is that issue of, okay, how do you want to build this, which does come up, but it's hard to be able to determine what the real limiting factors would be. Because you're looking at, okay, what are the use cases that would actually push the network to its limits? And are those different than the use cases which would push a walled garden to its limits as well, but because they internalize the infrastructure, you just don't see where that happens. Because they also have to deal with these problems, they just kind of do it internally in terms of what the actual connection between distributed nodes of some sort are. Does that answer that?
Yeah.
Okay. Okay, is there anything else, or are we good?
Sure, I have a question.
Sure.
The client, when it's trying to locate a server or figure out where it's connecting to, how does it do that? And the server configuration could change in the sense that, is there a centralized location where it does sign on, or when it's connecting?
No,
You have a multiple server setup.
in this situation, the idea is that it's all, what you'd actually end up doing is, if you wanted some sort of white pages, so the question is, how do you actually find other users, and how does your client application actually find something to connect to, right? Yeah, so if you wanted, you could build something that was effectively a white pages for this, because again, you're looking at a system which is without central authority or structure. So there is no, as a side effect of the way it's implemented, there is no single place where you'd say, I want to go find the users. You'd end up with a situation where you kind of like you have now with actual data on the internet, where there's search engines and things like that that connect it. It isn't all in Wikipedia, even though it might actually be. So there's the way that your actual clients, the client applications know how to do this is because they're all connected to an identity and they know where that is. So that's actually how they maintain that connection. Now, how the actual identities find each other is through the users actually building the connections. So this is, it just means that instead of saying, oh, look me up in this directory somewhere, you'd instead do something like say, yeah, here's my identity, like here's this URL, or here's this QR code, because we're standing in front of each other holding phones anyway.
So that diagram you had up there with the 3 different servers, and if you were connecting to that, it's an add-on lookup essentially?
There'd be no lookup across them, because that would require that there be sort of a leader. Now, it's possible that you could build a system where they knew about each other, but that would be kind of an add-on. Yeah.
Is it kind of like email in that sense? Like there's no central database of everyone's email addresses? Right?
Yeah.
You give someone your email address and that's how they communicate with you.
Yes, thank you. That's actually a very good way of explaining that it's like email in the sense that, how do you find the email address of someone you're looking for? Well, you ask them for it. And that's how those connections are built. There is no central authority.
Right, but I was under the impression that those 3 systems were operating under the same name. So how do I know which instance to connect to? Or it doesn't matter, you connect to one and then you're connected to all?
They're all completely independent. So it's not like you're a name. It's more like it's kind of like how with email you have this idea that there's a user and a server, and that gives you your 2-level namespace. In this situation, they use URLs, and those uniquely identify them as well, because that provides you a namespace that's global because of DNS, right. And then sub-namespaces just because of how the server is organized.
Right, that makes sense.
So that way they'll end up, they are all globally unique as a side effect of that kind of 2-level namespace idea. Is there anything else? Any other questions?
In this case, let's thank our speaker.
Thank you.